All the world's a page, and the men and women merely pointers and clickers. We're going to start with this guy today, Sir John Harington, poet, author, the saucy godson of Queen Elizabeth, but he is best remembered today as being an inventor. And the thing he invented was one of those really crucial, pivotal technologies without which modern society is unimaginable. Without his invention, we would not be able to live in large cities. We would not be able to collect a lot of people together to do the kind of work that we do. We all owe it to him. And what did he invent? This is it. This is the flush toilet. You might recognize some of the components here. There's a cistern up at the top. He drew it with fish in it. It probably didn't really have fish in it. There's the seat board with a hole in it, and then the stuff would drop through, and there was a lever labeled J that you would turn that would cause the water to drain. He designed this specifically for the Queen. And this was a really important invention. We could not live the way we do without this. And like most important inventions, it was completely unappreciated at the time. The Queen, in fact, refused to use it. That was because it made a lot of noise, and she didn't want everybody in the castle knowing that she was doing her royal business. So it took a couple of centuries, literally centuries, before it found its market and took off. It also depended on some additional discoveries and inventions integrated into it, like the S-trap and the float valve and the siphon. Once all that stuff got in there, it took off. But Harington wrote a book about it. And the name of his book was The Metamorphosis of Ajax. He called that device the Ajax in 1596. Flash forward now to this guy, Jesse James Garrett. Actually looks a lot like Harington and sort of dresses the same as well. He is a designer living in San Francisco. He's also a consultant. And one day in 2005, he was consulting with some people on web applications, and they were doing this really interesting stuff where they would have interactivity happening in the browser in a way that people hadn't seen much of before. And the developers asked Jesse if he could convince his management that that was an okay thing for them to be doing. So he thought about how he would present that to them and gave a lot of thought and composed a memo which got pushed to the web, and huge excitement was created around it. And while he was thinking about it, he tried to come up with a name for this mode of application development that he was promoting. And he came up with that name in the shower, or so he says. I think it'd be a better story if he had been on the pot when he invented it, doing his royal business. But he contends it was in the shower, so I guess we have to believe him. But coincidentally, he also called it Ajax, standing for asynchronous JavaScript and XML or something, I don't know. And it took off. And so the web, which was pretty close to dead at that point, suddenly became an application delivery system, the biggest in the world, and everything has taken off since then. And so the browser is still an interesting appliance because this mode of application delivery was discovered. So let's back up a little bit and look at where the web came from. There used to be a thing called word processing, which were specialized single-purpose devices which were used to do editing of documents. And there were sort of two branches of that. There were the binary proprietary things, which came out of companies like IBM. And they went through a number of iterations: standalone systems, shared logic systems, and then finally personal computers. Then there was the other branch, textual open systems, where instead of encoding the stuff in proprietary binary formats, they were displayed in the open. So there was a battle between what you see is what you get and the corollary, which is what you see is all there is. In the markup languages, there was a potential of doing things which weren't easily represented visually, which were still desirable. The earliest of these systems was called runoff. This ran on some of the very earliest time-sharing systems. It was also ported to batch systems, runoff programs, proliferated. They were on virtually every mainframe of the day, usually in wildly incompatible forms. I even saw one that worked with punch card input, and punch cards only knew how to do uppercase. So there were additional markup codes that you could put in the markup for indicating which of those uppercase characters should be treated as lowercase and which ones should stay uppercase. So the encoding was that if the first character on a line is a period, then it's followed by a cryptic code which indicates how you're going to be formatting the thing. So in this case, we skip a line, then we tab for, offset for, skip another line, and so on. And then the text in between those commands gets filled into paragraphs. So the line endings that we see in the input is not necessarily the line endings we'll have in the output. And that turns out to be a good thing, too. There was an attorney at IBM named Charles Goldfarb who thought he could do better than this. So he started experimenting with something that he called generalized markup language, or GML. And it went through a number of iterations over many years. And here we see a step in that evolution. He has the command starting with a colon, and then a cryptic code, and then a period, and then you could have text on the same line. So that was starting to get a little bit more agile than the earlier markup. Now, any of you who are familiar with HTML might notice some eerie similarity with some of the codes that you're used to, and that's not coincidental. This is the crap that HTML evolved from. In fact, you probably recognize all of the codes except for maybe the EOL, but you can probably guess what that does, right? So that went through some iteration as well. It went from that to : OL, and then eventually he stumbled onto curly brace or angle brackets, and it was like, whoa, angle brackets. And then the thing took off. But before then, there was a thing called Scribe. Scribe was the first text processing system that got it right, that got the separation between the structure of the document and the thing that got printed out, so that you put no format-specific stuff in the document. It was all just perfect. It was developed by Brian Reed at Carnegie Mellon in 1980. He tried to commercialize it, but that didn't go real well. But this was really one of the best document processing systems we ever saw. While it was not commercially successful, it was influential. So things like LaTeX, which is an implementation of Scribe in Donald Knuth's text system. And it was a really simple, elegant language. There was only one reserved character, which was the @ sign. And you could have commands. So you'd say @ in a command like quote, and then you can have some text which is bounded by a pair of delimiters. And he had 6 or 7 sets of delimiters that you could choose from, including angle brackets. And Goldfarb saw that and, oh, I didn't know you could do angle brackets. That's really something. So that's something that he learned from Scribe. There's also a special form where you could say begin, end, and then put the name of a command in quotes, and that would do everything in between. And that completely freed you from having to worry about escape characters or unmatched things, because it was just really reliable. So it's a much simpler format than HTML, but it's much easier to write. It's much easier to get correct. It's much easier to process. It was better from every angle. And unfortunately, the thing that Goldfarb copied from this was the angle brackets. He missed almost everything else. Had Tim Berners-Lee been more knowledgeable about document processing systems at the time he designed the World Wide Web, the web would be a better place. The world would be a better place. But he didn't, so we're stuck with something else. Now, one of the things that Scribe could do was deal with bibliographies. So he had special commands, tech report and book, among others, in which you could say, you know, this is some publication that I want to reference within my document. And you'll notice he's got key value pairs separated by commas. And that, in fact, this looks a lot like JSON. I think this is the first time that data was represented in a document format. And this is where the idea of XML came from, ultimately, that we can use a document format in order to deliver data, because he had demonstrated it here in 1980 in Scribe. And you look at it, and you know, it makes sense. Like, you know, the strings have quotes around them, but the numbers don't, because quoting numbers would be insane, right? But he didn't do that because he was not insane. So runoff led to GML, which led to SGML, which eventually led to HTML. Then Scribe and Tech led to LaTeX, and Scribe influenced the evolution of SGML. So HTML was not state-of-the-art when it was introduced in the late 20th century. It was intended for simple document viewers. It was not intended to be an application delivery system. In fact, there were a lot of features in it which were hostile to the idea of being an application delivery system. The web is interesting today because it's an application delivery system. So it lacked a lot of what it needed. In fact, a lot of people looked at the World Wide Web and said, no, this is, even as a document system, this is inadequate, and for all the other things that it's promising, it's inadequate. But it took off anyway because it looked like the thing that we wanted, even though it wasn't what we wanted. So the web standards have grown from a naive hypertext system under intense, highly unstable competitive pressure. And you had Netscape and Microsoft trying to destroy each other by gaming each other's standards. And it wasn't designed to do all of this Ajax stuff. Its success is due to a lot of clever people who found ways to make it work. And ultimately, they were able to figure out how to make it work because JavaScript was in the browser. And JavaScript is sort of the universal workaround tool. Whatever was wrong in the design of the browser, with JavaScript, you could make it work. So HTML was a huge improvement over SGML, primarily because it was much simpler. There was a lot of crap that Tim Berners-Lee removed from SGML. And he also decided to make it more resilient. SGML was a very brittle system, and its advocates were very much in favor of its brittleness. HTML would probably have succeeded or have failed if it had been similarly brittle, because the early web masters, early web developers were all extremely incompetent and couldn't do things like match brackets. So the browsers competed with each other by seeing who could make the best sense out of the worst markup. Today, those conventions are primarily used by attackers, cyber criminals, and people like that. They're not features that any of us should be taking advantage of, but it's still in the browser. In fact, a lot of it has recently gone into standard. So in the original vision of the web, authors had virtually no control over presentation. Whatever the browser decided something should look like, that's what it looked like. You could say something was a heading or something was a paragraph, but you couldn't indicate what a heading should look like and what a paragraph should look like. That turned out to not satisfy the market at all, so people very quickly started gaming the browser, trying to figure out a way to get stuff in. So early on, there were experiments like making GIFs to represent particular kinds of spacing and sticking those in the middle of your text in order to get stuff to line up the way you wanted. Things which are today rightly considered to be extremely bad practice. There was a time in the early web when that was called a good practice. It turns out most of the people who decide what good practice is and bad practice is have no idea as to which is which, and so you see those flip a lot. And you still see today in bad coding practices, which are sometimes called classitis and IDitis, where in order to try to get control over the display of things, you resort to mechanisms which are easily misused, and so we misuse them because they're not good alternatives available. And again, HTML did not anticipate applications beyond simple document retrieval, and we have gone way past that. HTML is also confused about how outlines work. In fact, it has two conventions for outlining which work completely differently. You have things like ordered lists, which nest, and you have things like headings, which don't, but both produce outlines. It's at least confusing. And then, obviously, a web page is not a page, right? The closest technology that it matches is a scroll, a thing with no specific fixed length, which is as long as it wants to be. And scrolls are ancient technology. You know, pages are a relatively new technology, but the web hasn't caught up to that concept yet. The SGML crowd hated HTML. They hated that Lee so radically simplified it. They liked that it was as complicated and confusing as it was. And they got control of W3C and started trying to push their favorite conventions back in. And so we saw things change, like P changed from being a paragraph separator to being a paragraph container. And it became necessary to have closed paragraphs where in the original formation of HTML, paragraphs were not closable. And then there's all that stuff about semantic markup, which doesn't make sense, but you see that has sort of consumed W3C. W3C got pretty radically misdirected when they decided that they were going to take on the job of fixing SGML by creating XML and producing XML as the universal format for all documents and all data. But it turns out the web has rejected both of those. The web rejected XML as a document format and as a data format. So HTML survived, even though W3C intended for it to be replaced by XHTML, because it really didn't work or do much that we wanted. HTML, for all of its problems, is a much better document format than XML. What might have replaced it would be some kind of markdown, because it turns out that if HTML had been an adequate document language, or if XML were a better one, then we would write in that. But more and more, you see, we're moving to markdown languages, which are much simpler, often more scribe-like. Then there's CSS. CSS cascading style sheets. They were designed for documents, primarily technical documents and legal documents. They were not designed for application presentation, but that's mostly what we use it for now. They were not well suited for doing the thing that they were designed for, and they're even less suited for what they're actually being used for. There's an unhealthy separation of structure and presentation. You get long, fragile lists of self-contradictory rules, which often tend to grow and grow and grow, and it's very difficult to winnow a set of styles down to something that's actually usable. They tend to be very difficult to maintain. There's no modularity. It's just awful. Each rule has two parts, a selector and a declaration, which is not in itself bad, but the patterns for selectors get extremely complicated, and the way that they can interfere with each other is extraordinarily complicated. So the whole system is really difficult to understand, very difficult to use. There are some people who have figured it out, and once they figure it out, they become extremely devoted to it. So these are the big problems I see in CSS. The biggest one is its lack of modularity, that you might have several components on a page, and they'll probably be implemented and designed by different teams, possibly in different companies, but you need to put them both on the same page. There's a very good likelihood that they're going to interfere with each other in a bad way. Selector management is complicated. The rules of specificity are complex and difficult to manage. There are some experts who have recommended not using all the generality of the language and using a very specific pattern of specificity, because that's the only thing that's manageable. And that's probably really good advice, because using CSS as it was designed is really unworkable. Declarations are too weak for modern applications, particularly as we're trying to deal with smaller and smaller screens. Having a document which makes sense in all configurations is not something that CSS was designed for. It was not designed for dynamic content, and we do more and more dynamic content, so that doesn't fit. And it's unimplementable. Okay, so the CSS2 specification was published. Nobody could implement it. So they went back to the committee and created CSS 2.1 by asking the browser makers who was able to get anything working. And they took a list of all the features that anybody was able to get working, and they issued a new spec containing that. We're now working on CSS3, which has divided into many, many, many specifications. The whole sum of all that stuff is so huge that it is likely to never be implemented. And so instead you have every browser maker making his own selection as to what subsets of that they're going to try to implement. That's not a standard when everybody is choosing their own little bit of the universe to do. So sometimes it's like watching cops when you talk to CSS designers. You know, CSS isn't bad, you just don't know it like I do. You know, I know sometimes it hurts me, but, you know, it's my fault. I make mistakes. I don't know why I make mistakes. I do. You know. It's not CSS's fault, but it is. So if that's all there was, the web would have been replaced by now. There were lots of contenders for the thing that was going to be the web, you know, Flash and Air and Silverlight and Java and lots of other things were intended to do what the web is doing. But the web won. So in 2000, George Colony, who was the chairman and CEO of Forrester Research, predicted something that he called the X-Internet. And he wrote on his website and in lots of other places, another software technology will come along and kill off the web just as it killed News, Gopher et al. And that judgment day will arrive very soon in the next 2 to 3 years. This was in 2000. He was saying the web was just about dead, and a lot of people believed him. By the way, this is no longer on Forrester's website, but it is at archive.org, so you can go and look it up. So a lot of people believed him, including people at Microsoft. So when Netscape failed, they took Colony at his word and said, okay, so the web is done. So they disbanded the IE team and put them on Avalon designing the X-Internet, the thing that was going to replace the browser. So they were surprised when the web didn't die. And the reason it didn't die was because of JavaScript. If JavaScript had not been in the browser to save it, it would be dead, 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 and we'd be working on something that was probably a lot better. But we're not, because JavaScript is so damn good that whatever was wrong with the DOM and whatever was wrong with CSS, whatever was wrong with the whole deal, we could make it work with JavaScript. The API that the browser presents to JavaScript is called the document object model, sometimes called the DOM. And most people who use JavaScript, who say they hate JavaScript, hate the DOM. And they're confused because they don't know what the separation is between the language and that terrible API. And it really is an awful API. If you took your favorite programming language, deleted all of the standard libraries, replaced them with the DOM, you would hate that language. You'd say, this is the worst language. It's really awful. But unfortunately, that's the only API that the browser offers, and so that's the one we have to use. And it was invented by Brendan Eich, the same guy who invented JavaScript. He got a lot of good parts into JavaScript, not so many good parts into the DOM. He was influenced by a book on HyperCard. He had never actually used HyperCard. Based on his reading, he actually did an okay job, but it would have been better if it had been designed by someone who had experience with it. There were a number of people over the years who have added stuff to it. One of the most important was Scott Isaacs of Microsoft. For IE4, he came up with the idea of generalizing the DOM so that every node was modifiable in a uniform way. And at that point, it took a step forward as being a semi-rational API rather than a completely irrational API. Unfortunately, Microsoft didn't finish that work, and so they still left it in a bad state, and that's the state that it's still in. In the original Netscape model, not all elements were scriptable, and those that were scriptable were each scriptable in a different way. This was influenced by the HyperCard model, where there were certain things you could do to a button that you couldn't do to a field and so on, and so that specialization found its way into the DOM. Microsoft fixed that, but they didn't finish it. So this is a flowchart of an early browser. So the Mosaic browser or earlier browsers would have worked like this. So you input a URL into the fetch engine, and we'll go out on the network and get a document, and we'll put it in the cache. And then that gets handed to the parse engine, which will parse it and turn it into some kind of a tree. And that will be given to the flow or the layout engine, which will figure out the size of all of the components in the document and where they should be placed relative to each other. And that will create a display list, which could be a separate structure or it could be an annotation on the tree. And that's given to a paint engine, which will then turn the thing into pixels that you can put on a screen or send to a printer. And all browsers kind of do that, even still. When the Mosaic browser was created, one of the interesting features that they added to it was the image tag. That was one of their innovations. And the way the image tag worked was it would parse and it would find something that said image, and then it would stop parsing, throw that URL back to the fetch engine, wait for it to arrive, then it would continue parsing. So if you were on a slow network, it could be quite a long time before you saw anything, because it wouldn't get to the paint engine until everything had been loaded. Now, when they developed it, they were running in a supercomputer lab with high-speed networks, or high-speed for the time, so it didn't matter. But when it went mainstream, at a time when most people were still reaching the internet through dial-up modems, which the old-timers will remember were not fast, it could be a long time when you hit a site before you saw any pixels. So an innovation that was added to Netscape 1 when it came out was when the parse engine saw an image tag, it would put a placeholder in and continue running. And then later, when it was notified that the images that it had skipped over were available, it would then redo the flow and redo the paint for each image as it arrived. So this actually slowed down the total time that it took, lengthened the total time it took to display the page, but you started seeing pixels immediately. And so it produced a much better user experience, and people thought it was fast, even though it wasn't. So it turns out for a lot of performance-related stuff, apparent performance is much more important than actual performance. So how fast it feels is usually more significant than how fast it is. Netscape 2, Brendan added scripting. And so there is a loop now, an event loop, that allowed for documents to become dynamic. So we still have the same flow and paint functions that we had before, but now we have event generators. So after the painting is done, it can look around and say, has anything happened? Has a user clicked on anything? Has anything come in from the network? And if so, then a script which is associated with it will run, and it will run to completion. And while it is running, it can be modifying the tree that we saw earlier. And then we will reflow, and then we'll repaint, and so on, and we keep doing. And so browsers still do this. They're still in the loop. Some aspects of the flow might happen during the script phase. Some will happen after. But basically, every browser implements this loop. And this turns out to be a good thing. This was one of the features that was copied from HyperCard, the event-driven UI model. And this works pretty well. This is one of the good parts, maybe, of the browser. Another of Brendan's inventions was the script tag. This was intended to embed script on the page. That turns out to be a bad practice. We don't want to be putting the script on the page. Brendan allowed for it in these explicit tags and also implicitly in things like event handlers and other places where you put stuff. That's a really bad practice that shouldn't be done anymore. There was one of the conventions in HTML is that if you have a tag that the browser doesn't recognize, simply ignore the tag and keep displaying whatever was inside of it. So when programs written for Netscape 2 started being displayed on Mosaic, the script started appearing as text in the document. It was like, oops, that's embarrassing. They had a no-script tag, but that was also ignored. So that didn't help. So the convention, the workaround was to put SGML comments around the script in order to keep it from displaying. I still see people doing this. There's no need to do this unless you expect you're going to have to run on Mosaic or Netscape 1. If you're not specifically targeting those two browsers, stop doing that. You don't need to put those in your programs anymore. Microsoft added the language attribute to the script tag because they intended to kill JavaScript with their own VB script, which is a scriptable version of Visual Basic. Fortunately, that effort failed. Thank you. But the language tag is still in there. Netscape started using the tag to do versioning, because they were still fiddling with the language. And so they had JavaScript 1.2, 1.3, 1.4, which were all introducing incompatible changes. And they were using the language attribute to moderate that, and that turned out not to work at all. That was sort of a failure. So that was deprecated. The source tag was added, which was brilliant. So the source tag allows for loading script from the web. So it doesn't have to be embedded in the page anymore. And that has a lot of advantages. For one, it means we can now cache scripts. You can't cache scripts that are embedded in the HTML. It means that you can minify in gzip the scripts, which makes them much smaller. And that still has a big impact on initial performance of the page. Unfortunately, you still have to have the close script, even though you're specifying the script tag or the source, and it doesn't make sense, but you have to do that anyway. Then eventually W3C added the type attribute. The official type of ECMAScript or JavaScript is application ECMAScript. And there are many browsers that now know that. But it turns out the script tag is not the authority on what the type of the thing you're loading is, it's the server. So if you're loading stuff from a server, there's no point in specifying the type because the server will say what the type is. Even so, W3C's rules require that the type attribute be there, even though it's ignored, which I think is silly. It turns out all the browsers know that. So if you leave the type attribute out, it works fine and always will. So my advice is leave it out. There's no sense in putting stuff in which might be wrong and is certainly unnecessary. So there's a devotion to web standards that is completely unjustified because overall I think they're pretty awful. But you see web developers who, treat them with almost religious fervor. And the gods gave us web standards, and deviation from the web standards is the source of all evil. There's no truth to that statement. The web statements or the web standards are in fact the source of considerable evil. One of the worst of those is document.write. This was another of Brendan's things. It allows JavaScript to produce HTML text, which is not by itself a bad idea, but the way he implemented it was wrong. Because what you're doing is inserting text into the HTML stream as the stream is being parsed, which is insane and crazy and hard and problematic. One of the problems is that when you do this, it has a big impact on what's going to happen next. If you do it before the onload event is fired, then HTML will be inserted into the document. But if you do it after, that HTML that you wrote completely replaces the document that was already there, which is never a good thing to have happen, but it happens. So I recommend never using document.write. We have much better affordances now. There's an industry, though, that is built on the use of this absurdity, and it's the advertising industry. You see ad placements do this all the time. In fact, it's not uncommon to see an ad which, when it gets placed, will immediately do a document.write, loading another script, which will do a document.write, loading another script that will do a document.write, and then show the ad, which significantly slows down the loading of the page and completely removes all possibility of security because there's no way you can know what ultimately is getting loaded into the page and what runs. Everything that runs with full authority. it turns out script files can have a big impact on page loading time. This is because browsers have historically been incompetent about how they do caching and management of network sources. So as a consequence of this, Steve Souders determined that we should place all of our script source tags as close to the bottom of the body as we can stand. Now, you can't always put them at the bottom because you might have something that is happening that is dependent on a script already being there. But to the extent you can, you need to do that. And that's because the browser is prepared for document.write being fired from any script, and that document.write can change everything. And so it's really pessimistic. When it sees a script tag, it stops processing. So it stops parsing, stops looking for additional images that it can load until that script gets loaded and compiled and executed. And when only after it returns will it then continue parsing the rest of the HTML. So that means that any images that you're trying to load that are placed after the script tag will all wait for that script tag. All parallelism is lost. It's horrible. And HTML or HTTP is already horrible in terms of its performance. Adding this can add many seconds to the startup of an application. He also recommends placing your CSS links as high in the document as possible, as high in the head, because it turns out if the browser sees that there are any CSS links lower in the document, then it will suspend display update until that gets read in and parsed and processed, which will slow down the appearance of any pixels, and users will think nothing's happening. It's also recommended that you minify and gzip the script files because making them smaller really does make them load faster. And you also want to reduce the number of script files as much as possible. Now, this is a bad practice that looks like a good practice. Because HTTP is so inefficient, you can actually get a big performance benefit from taking all of your separate script files and mushing them all into one file and loading them as one. But it turns out that causes other problems, that there might be sloppy coding in one file that can actually cause syntax errors in the following file. It also makes it much harder to do cache management because you might have one script that's used on every page, but there are other scripts that are not, but you lose all benefit of that commonality when they're all stuck together into one file. So cache management becomes harder. So I'm hoping eventually the browsers will become competent enough that most of this advice will be unnecessary. But at this moment, I think it still is. Yeah. The minify tool I would recommend is JSMin. JSMin has the benefit of being the fastest because it is the least smart. It does not attempt to parse and understand the thing as a program file. It just looks for certain combinations of characters and white space. JSMin has an option that it'll take a command line argument and turn it into a comment. So as part of your minification process, you can also insert comments back in. Okay, so Microsoft and Netscape during the browser wars were engaged in a crazy game of leapfrog, where each was trying to get over the other, capturing idiot webmasters. And both were really effective in playing that. And W3C attempted to moderate that struggle, but they were not very effective, and in some cases added their own craziness. The DOM is about a document tree, the document object. And this is what such a tree looks like. So here we have some HTML text, and over here we have the tree that will expand into. And there's some interesting things to notice. One is that the root of the tree is the document tag, which in the browser is the document variable or window.document. That'll be that node there. You'll notice that in this HTML I specified everything, all the tags in lowercase, but here they're all in uppercase. Initially the web looked like it wanted to have uppercase conventions, but then there was, well, maybe we shouldn't, and there was some mind changing, and they got kind of stuck in this middle form where they tolerate lowercase but will force things to uppercase in the internal representation. That's how they ended up normalizing, which is against the convention that everyone else is using, and we're sort of stuck with that. So if you need to be aware that the names will probably be in uppercase when you look at the DOM, particularly if you're searching for certain patterns. I didn't specify a head here, but it went ahead and inserted a head into the tree. So there's some places where the tree will be bigger than you intended or expected. Another case where that would happen would be in a table. You might say table, then a TR for a table row. It will insert a T body into that for you. And that can be confusing if you think you understand what the structure of your table is because you wrote the code and you start walking the DOM, you might end up not being where you think you are. And then the headings appear in the source to be nested in some way, but in the tree they're not. They're just various kinds of paragraphs. And then finally, the text that's in between will be here. Now, in this case, this is the tree that early versions of IE produced. All the other browsers produce a much uglier tree. And that's because the modern HTML rules require that all of the white space in between those be captured and put into the tree, even though it's all irrelevant and noisy. So in those cases, this tree would be much furrier than this tree is. But I'll use the Microsoft tree because this is a case where I think they actually got it right. And then we're forced to change it because the world insisted that it stay wrong. So this is that same tree, but I'm going to look at a piece of it from a slightly different perspective. So all of the nodes in the tree are linked together. Every node has a first child and a last child link. So the first child of the body is the H1 tag, and the last one is this paragraph tag. In a real tree, the last tag might actually be some extraneous white space, but we're going to ignore that today. And then each of these has those same two links. And since each of these has only one child, both of those links point at the same node. And these are the neglected middle children in this family of nodes. They don't actually get direct pointers from their parent. It's so sad. But there are more nodes than that. So there are sibling pointers. So there's next sibling and previous sibling. These guys are all siblings because they're at the same level in the DOM tree. These guys are not siblings, they're cousins. And we don't have cousin linkage in the DOM, so you don't have to worry about that. And then every node has a parent, and there are parent nodes, or parent node pointers, which will point up the tree. And the body will then point up to the HTML and then point up to the document root. Now you might, so part of what you do in manipulating the DOM is manipulate these pointers. And you might think it can be really easy to royally screw things up if you get the pointer updating wrong, which is absolutely true. And so for that reason, the DOM does not allow you to directly modify any of these pointers. It provides an API which will do that for you. So you'll tell it to insert something or delete something, and it will then go and fix up all the pointers for you. Now, it turns out for most purposes, to traverse a tree, you don't need all of these pointers. You can get by with just 2 pointers, because you've got a general binary tree. So you got the cars and you got the cooters, and that's enough to traverse. So having this, I could write a function that would walk the DOM for me. I could pass it a DOM node and a function, and it will then go through and visit every node in source order and call the function on that node and then go down into all the children. So, let me show you an example of how you could use this. So early on, the browsers did not provide get elements by class name functions. It's there now, but if you're having to run on an older browser like IE6 that couldn't do it, you could implement that using the walk the DOM function. And what this will do is walk the DOM going through the document body and all of the children within it, and then looking at the class name attribute of each of those, and if they match, then we'll collect it. So in addition to the pointers I already showed you, Every node also has a collection called child nodes, which will contain a complete list of all the things. So that's another way of getting at the neglected middle children. Okay, so this is how you can retrieve nodes. There's document.getElement by ID. Watch the spelling on this, capital I, small d. It's really easy to get that wrong. There's get elements by name, and there's get elements by tag name. These are retrieval tools, and the modern DOM contains additional methods as well. Once you get a hold of a DOM node, there are things you can do to it. It'll have attributes that correspond to the properties that the markup could have that you can manipulate. So, and each kind of node might have a different set. So an image node has these. These are the ones that seem to be common to all browsers. Every browser will have additional properties that other browsers don't have. My advice is stay away from those as much as you can. We should try to keep to the common set so that our stuff runs in as many places as it can without surprises. Now, the place where my advice is a little problematic is, well, I was going to give you a heads up about Opera, but they sort of went out of that business, so I guess you don't have to worry about them anymore. Opera had a tendency to try to do things correctly, and it turns out there's still a lot of webmasters out there, and so a lot of stuff would frequently not work on Opera because they would do things right. Anyway, once you get to one of these properties, you can simply assign a value to it using JavaScript conventions. So if I want to change, the width of something or the source URL or something, I just assign a new value to it. And there are a couple of ways you can do that. There's the old school way. This is the way Brendan originally set it up, that you do it just like JavaScript. Then the new school is more a Java-like API, where you can call get attribute and set attribute to do the same thing. And both of these will work. Some people like to do this because they enjoy typing. You can get at style stuff. You can get at the class name. You can get the style object for a node and get any of its properties. You can get the current style, which is what's currently on the screen, which is not necessarily what was specified in the markup because it could inherit from style sheets and other things. So IE provided a very nice way of getting at the current style. They had current style would compute what was currently on the screen. W3C came up with this thing, document.defaultView.getComputedStyle of node, empty string, get property value style name. Really horrible. I mean, this is so bad. This is a Java API, right? The guys who designed this had no understanding of Java, or of JavaScript. This is not how you would design something in JavaScript. This is Java, right? And that's how you do it. And if you're working on a modern browser, that's how you have to do it, which is really horrible. I need to rant for a minute. So we've got CSS and we've got the DOM, and they're both talking about style attributes. Both systems were designed at about the same time, and the designers of both of those systems were aware of each other. The designer of CSS knew that people were going to be using programming languages to manipulate CSS, and yet they put minus signs in between the keywords, knowing that minus means subtraction in most programming languages. They didn't care. They didn't care about you. Then at the same time, the people doing the DOM knew that CSS did that. So they could have come up with a convention saying, well, we'll have underbars. So a simple search and replace, underbar, minus sign, it'll work. They didn't. They chose camel case instead. So there's not a trivial transformation going from one to another. They could have made this like a system, and they didn't. And so you have to always be aware of which namespace am I in. At this moment, am I in CSS space or am I in JavaScript space, in DOM space? It's really confusing, and it's really easy to make errors here. Then even worse, JavaScript had a profoundly stupid reserve word policy. So words like float were reserved even though float is not used anywhere in the language. So you couldn't say .float to reference the float attribute of a property. So they came up with CSS float, or what was the other one? A different browser chose a different alias for the same thing. Again, just profoundly stupid, unnecessarily stupid. And we're still living with this. This is part of the DOM API, and it's something you have to be very much aware of. And if you're using an API that someone else wrote that's intended to disguise this stuff from you, and you absolutely should, no one should ever want to touch this crap directly. You want to be using an Ajax library that covers this. You have to be aware of which convention is the library using. Are they using the CSS rules? Are they using the DOM rules? It's not always obvious. So again, it could have been like a system. It really could have. It would have been easy, and they chose not to. So I showed you how to retrieve elements and how to modify elements. You can also make elements. And there are a number of ways to do that. One is you can say document.create element and give it the name of the tag, like p or div or whatever, and it'll make one of those for you. You can also ask it to make text nodes, which are like the other things, except they're just strings. They're the things that go in between the tags. You can take an existing node and clone it, which makes a copy of it. And if you pass true to the clone node method, then it'll make a deep copy. But it won't be a perfect copy. So you don't get the event handlers, and you don't get other sorts of things that might have been attached to it. You just get those nodes. Now, once you have those nodes, those new nodes are not visible yet. They won't be visible until you link them into a document which is currently being displayed. And there are methods for doing that. There's append child, there's insert before, there's replace child. And these are crazy in that the API is from the point of view of the node and not of the parent that you're trying to manipulate. So you have to do things like, I have to specify old twice here, which is nuts. Again, the guys designing this API, I don't think had ever written a web application. They just had no knowledge about how this language was going to work. They just made things unnecessarily bad. We see it again. If you want to remove a node, you can't tell the node to remove itself. You have to tell the parent to remove it. I hate this stuff. Now, the original design of the web said that if you had any HTML text that you wanted to cause inserted into the document, you could either do document.write, which you don't want to do because it's terrible, or you could parse it yourself. They did not give you direct access to the HTML parser, which is one of the few things that the browser is really good at. Browsers are great at parsing HTML, but they didn't give you an API until Microsoft created something with a terrible name. They called it inner HTML. And it's an attribute and not a method. I think something this active, this dynamic should have been a method. You want to pass it a string and it goes, I'm going to parse it and I'll stick it in the tree for you. But even so, at least you got access. And all of the other browser makers recognized, yeah, this is actually important. People need to be able to do this. And so they all did this, even though it wasn't part of any web standard. But there's a security hazard because by setting a property, you can cause stuff to get bound into your document, which maybe you were not aware of, including scripts and other nasty things. So it's something you need to use very, very cautiously, but it's sometimes a necessary thing. So there are two ways that you can get new content into an existing document. You can build or clone elements and append them, or you can assemble an HTML string and then do inner HTML on it. So which one should you do? I think the answer should be favor the one that's going to give you the cleanest code, that's going to be the easiest to maintain. One of them is usually significantly faster than the other, but I recommend you not consider that in making your decision unless you know that performance is really going to be a problem. And if that's the case, then you want to use inner HTML because browsers are really good at doing inner HTML. And in fact, if you're doing things like building up nodes, you want to do it in probably the worst way, which is to assemble them all and then take the finished subassembly and stick that into the document. If you stick each one in as you create them, it's going to do a repaint and a reflow on every one, and that significantly impairs performance, so you don't want to do that. No matter what you do, the DOM is horrendously inefficient. I see a lot of people fretting about how to make their JavaScript faster, and they'll do stupid things like unrolling loops and using bitwise operators in inappropriate ways and stuff like that, thinking it's making their programs go faster, and it has absolutely no effect because all of the time in the browser is being spent in the DOM interface, and fiddling with your JavaScript in no way improves that. So you just need to be aware about how inefficient the DOM is and try to touch it as little as possible. There's no way you can not touch it, but you just have to be aware that every time you touch it, there's a cost. There's going to be lost time. You touch it and you wake up a couple seconds later. You just have to be aware of that. So the browser is dynamic because of events. We have an event-driven, single-threaded programming model, which is actually a very good model. This is one of the things that the browser got right. Events can be targeted to particular nodes. So very often the node which has focus will be the thing that receives an event, or the node that gets clicked on will receive the event. And that causes the invocation of event handlers, which can be associated with those nodes and those events. So there are a number of classes of events. For example, there can be mouse events, clicking and mouse over, mouse down. One of the reasons that the browser survived was because you got quite a generous set of attributes to deal with. Unfortunately, it leads to level confusion. You see, you've got low-level mouse events, you've got high-level mouse events, all getting mixed up in application code. And so you get really poor separation. It would have been better if the browser had been much clearer about this is a widget and that's where the widget code goes, and that's the application, that's where the application code goes, but it didn't. It all gets mixed up together. And it is possible to write good browser stuff, but most people don't. And it's because of this confusion. We see a similar thing going on with input events, where we've got the fundamental thing like key press, but then we've also got key up and key down and focus and that stuff. So again, you see a lot of confusion as to what's happening at what level in the application. There are a number of ways of associating an event handler with a node. Brendan's original formulation was each node would have on type properties. So on click, on mouse over, on key press, and so on. And you just assign a function to that property and it works. And everybody still implements that. But Microsoft came up with their own way. Node.attach event and the same thing. So they took what's an assignment and made it a method, which is not bad. In fact, I wish they had done this for inner HTML, because that's how inner HTML should have worked, rather than that form, which is what they ended up doing. And then W3C said, no, that's not enough typing. So let's make it longer, because we'd like to type. What good is autocomplete if you don't have things that are too long? So it's basically the same thing, except now on is not specified here, so it would just be click. And there's this extra parameter that you have to provide. Some browsers will let you leave it off, but some won't, so you always have to say false there. So if you wanted to write an event handler and have it work in all browsers, you would receive an event object and also be prepared for it not being there and going to the global event object instead. And then the event will tell you what the target of the event was. And depending on the browser, it was either target or source element. And it could be either one, so you had to be prepared for both of those. And then finally you could start dealing with the event. There were two modes in the early browser for how to distribute events. There was the trickling and the bubbling. Netscape implemented trickling. which was that events start at the top and then will go down the tree until it gets down to the target node. And any node along that chain going down could capture the event and keep it from getting delivered. Microsoft did it the other way, bubbling, where the event starts at the target node, and if the target node doesn't handle it, then it goes up to its parent, and then its parent, and so on until it gets up to the root. That turned out to be the right way to do it. So when W3C was looking at, okay, how do we unify these two perspectives? Do we do the one that was right? Or do we say, no, we'll do it both ways? Well, of course, W3C would insist that we do it both ways. So the wrong way gets into the standard and it's still there. So why is bubbling important? Okay, suppose you've got an application where you've got 100 objects on the screen. You know, maybe they represent photographs or something, and you want to be able to drag them all. So each of those elements would require its own set of mouse up, mouse down, mouse move, so on. That gets to be a lot of functions. You know, you could add maybe 1,000 functions to the page, and there's a cost to doing that. Or you could say, we'll do bubbling. So I only add one set of event handlers to the container of all of those, their common parent, and then you're done. And that common thing will then look at who was the target and go, okay, I'll do this, I'll call this function on behalf of that. And so you save a lot of time setting things up. And that could be beneficial. In modern browsers, it's maybe not that big a deal. I mean, Moore's Law has just run away so fast that the case that this was intended to solve may not be significant anymore, but at one time it was. Once a event is handled, you want to say stop bubbling so that, you know, basically don't tell my parents. I've got it covered, let's just keep it quiet. So you can stop the propagation, and there are two ways you can do that. And which way do? You have to do both, because depending on what browser you're on, it may want to do it one way or the other, and you want your code to run on all kinds of browsers. So you set the event's cancel property to true, and if it has a stop propagation property, you call it. Actually, you don't want to be doing any of this. You want to be using an Ajax library. It will be doing this stuff for you, but you know, I'm telling you this because you should know what they're having to do on your behalf. Another thing you might want to do is tell the browser not to do its default action. On some things, if you click on it, there'll be a consequence, like it might get focus or it might cause a form field to get submitted to a server or something, and you might want to prevent that from happening. And you do that by setting the return value to false and calling the prevent default method if it has one, and returning false from the event handler itself. If you do all those things, then propagation or the default action probably won't happen. So you have to worry a lot about performance in the browser. That's probably the hardest. Well, no, reliability is the hardest part. Performance is the second hardest part. So touching a node has a cost. Styling can have a big cost. Reflow can have a big cost. Repaint can have a big cost. Random things like node lists, which are part of the standard API, have a surprisingly big cost because they can cause a query to get repeated every time you touch something that looks like an array. It looks like a static structure that you should be able to touch, but it is constantly walking the DOM again each time you look at it. And in most applications, JavaScript has a small cost. So be really careful about where you do your optimization. Don't optimize where you're not spending time. And probably you only have a limited amount of time in which to be doing your optimization, so optimize that. Make the best use of the time that you have to do optimization with. Don't make unnecessary optimizations. There are some tools now which help. There's Speed Tracer that's available on Chrome. There's Dynatrace that runs on IE. These tools give you some insight as to what's actually happening in the browser. You know, when are we doing painting? When are we doing reflow? When are we running JavaScript and so on? What's contributing to those times? So you definitely want to be using tools like this before you start fiddling with your code. So these standards were developed in the context of intense competition, where Microsoft and Netscape were literally trying to destroy each other by messing with standards and getting away with it. Then, fortunately, finally, one of them failed. And not surprisingly, it was Netscape. And at that point, Microsoft abandoned Internet Explorer in favor of Avalon and .NET and what they thought was going to be the future, and abandoned the web because they figured it was finished. And then Jesse James Garrett, sitting on the pot, probably, invents Ajax, and the web blindsides Microsoft a second time. And it happened because of Microsoft. Everything that was needed to do Ajax was really because of Microsoft. They developed JScript, which was a very high-fidelity clone of Netscape's JavaScript engine. Had JScript not been such a high-fidelity clone, then JavaScript would not have been the universal fix-up tool, and Ajax could not have happened. They fixed the document object model. They made all nodes scriptable. That was a really important step forward into making it into an application platform. They developed the XML HTTP request, which is the mechanism that we use for doing the data transport for Ajax. Microsoft did that intentionally in order to allow this stuff to happen. So Microsoft declared victory and left the field thinking that the browser war was over, and it turned out it wasn't. That they had laid the seeds for their own destruction because 5 years later, Jesse James Garrett discovers Ajax. So JavaScript should have died with Netscape. There are lots of companies who invented proprietary programming languages, and when they went, their languages went, and neither was missed. But that didn't happen with JavaScript because the Ajax revolution succeeded on the goodness of JavaScript. That kept it alive. That's why it survived the company that created it. So in 2001, or in 2000, all of the browser features needed to do Ajax applications were in the field. Now, IE5, IE6, even Netscape 4 after a fashion had enough capability that you could do Ajax with those browsers. But Ajax doesn't happen until 2005. So there's 5 years where nothing happens. I think that's really interesting. Why did it take 5 years for Ajax to happen? The web was full of bugs and unstable. During the browser war, the browser makers were shipping new bugs into the web at a fantastic rate. And it takes a long time for those bugs to disappear. Not everybody upgraded their browser at the same time. And so they were actually making the platform worse and worse by increasing the set of bugs in the browser, not by decreasing them, because every fix would bring new bugs with it. So most people don't install new browsers. They replace their software when they replace their hardware. And some companies lock their machines down so the users cannot upgrade stuff themselves. So it took years to flush Netscape 4 and IE4 and 5 out of the market. It took about 5 years to do that. And so in those 5 years, the web became stable because Microsoft stopped shipping new bugs. IE6 stopped rattling, and became, while it was still buggy, we at least knew what the bugs were, and they weren't changing on us. And so that was enough to allow Ajax to happen. So the browser had been a great driver of innovation, and then it became an obstacle to innovation because nothing happened for 10 years. So web time used to mean that things happened really then it didn't. So with Ajax, the source of innovation shifted from the browser makers to the web developers. Very clever web developers started making Ajax libraries and sharing them. We had Bill Scott's Rico package, and there was Prototype, and then jQuery and YUI and many, many others. There are hundreds of them. And they're all free and they're all good, and you should all be using them because you don't want to touch the DOM itself. And so these library makers figured out patterns which were vastly more effective and more reliable than the patterns that the browser itself presents. And amazing thing about JavaScript is that a small amount of JavaScript can turn the DOM API, which is one of the worst APIs ever imagined, into something which is productive and at times even pleasant to use. Well, I just said that. It also turns out Ajax libraries are fun and easy to make, which is why there's so many of them and why you can't charge for them. Ajax libraries do lots of useful things for you. They provide portability so that it's easier to have your code run on all browsers. They protect you from quirks in brands and editions. They provide corrections because there are a lot of things that any browser will get wrong and they'll soothe that, make it right. They provide a much better model because the DOM itself is badly abstracted and badly designed. You can fix that with a good library. And most of them will provide a big set of widgets that you can use so that you can focus on the logic of what you're doing and not having to make a box work the way it's supposed to. So I predicted that there'd be a shakeout because there were a huge number of libraries and they were all good, but it didn't make sense to have so many because it made portability at a different level harder. So I predicted that there'd be a shakeout, that the number of libraries would probably be reduced to 1 or 2. And I predicted that one of them would probably be Microsoft's Atlas, just because Microsoft is usually one of the winners. And that prediction turned out to be completely wrong. We still have lots of Ajax libraries, and the number still seems to be growing. So the forces that I thought would cause the market to want to shake down didn't. In fact, the only obvious failure was Microsoft's Atlas, which was so bad even Microsoft isn't using it anymore. They're using jQuery now. So it turns out the Ajax application market is large enough to support a large collection of Ajax libraries. So I'm now predicting that the shakeup will not happen until mashups become viable, because then it's going to be important to be able to have code from different parties developed independently to run together. Currently, we don't have a security model which allows for that, but eventually we will, and then we'll want to get on common things. So given that there are hundreds of Ajax libraries, how do you choose? And it turns out it would take much longer to do a complete evaluation of all of the existing Ajax libraries than to build a new one from scratch. I'm not recommending that anybody build one from scratch, except that it's fun, but I wouldn't put it in production. So the Ajaxians recommended throwing darts. Just put them all on a board and throw a dart, and the one you hit, not bad. Since they're all good, it's unlikely you're going to make a bad choice. I recommend instead run them through JSLint. JSLint is an objective measure of code quality. Go with a good one. So Ajax is no longer special. For a while there were Ajax conferences, but those don't happen anymore because Ajax has become mainstream. So all web development now is Ajax development. So we don't need a special term of art to describe that. Ajax is just the way we make web applications now. That a web application is not a series of pages. It's a page that does some interesting stuff and maybe goes on to another page, but the interesting stuff that happens there is what it's about. So as a result, Ajax has become the dominant application platform and has successfully beat all of the other contenders. Perhaps unfortunately, but it did. I'm sad to tell you we still have the IE6 problem. For many years, IE6 was the very best web browser in the world. Certainly in 2000, it was the best browser the world had ever seen and continued to be the best browser for many, many years afterwards. But recently, it has become recognized as the worst browser in the world. And that's only true if you don't count everything that happened before IE6, which was much, much worse. And now we've got a new class of excitement going on. We've got HTML5, which is at war with HTML unspecified, where we've got W3C doing battle against the What Working Group, putting more and more crap into the web. Some of it good, not so good. They don't care. It's just more crap. So there we go. So Ajax is great. The DOM is not. But if you're using a good library, the DOM maybe doesn't matter so much. Ultimately, I think we should try to seek to replace the DOM with an Ajax-influenced API. We know what sort of API we want to work with because every Ajax library gets much closer to the ideal representation of applications than the DOM ever will. The DOM also has other problems. Its performance is horrible. Its security properties are inexcusable. We need to replace it, and we know what to replace it with. We want to replace it with something that looks like jQuery, except it has the right security properties. And such a thing would not be complicated. We just have to tell the browser makers and W3C, get serious about this crap. You're killing us. So one last thing I want to talk about, division of labor. One of the things that Ajax does is it changes the balance of power between the application and the browser, or the server and the browser. So where should the work happen now? The original school said you did everything in the server. And the model of the browser was that it's just a terminal. The server would figure out what to show, and it would send an image, some representation to the browser, which the browser would display. Then the user would click, the click event gets sent to the server generates something and sends it back. That turned out to be hugely inefficient, but that was the Web 1.0 model. So when Ajax started being developed, people were all excited, wow, we can do everything on the browser. And now the server is just a file system. And you're taking all the data. I saw some applications where they basically trying to replicate the database in the browser. Get all the data you're ever going to need, put it there, and so on, so you can just run there. That turns out to be really bad, too. Because network transport is so expensive, particularly for the new mobile devices, you don't want to send anything to the browser or to the client that the browser is not going to use. It's just too expensive to send stuff that it might use. You might want to be a couple of steps ahead of it, but you don't want to send the whole database over. That's just not a good place to be. So you want to seek the middle way. And the way I imagine this is you have a pleasant dialogue between specialized peers. And so they have a shorthand. They're almost like a married couple. They know how to talk to each other, and they can say just the minimal amount of stuff to each other, and it all works. And that's how you should think about designing your applications. You don't want to be sending huge amounts of stuff in either direction. You just want to send exactly what you need when you need it.